Hi folks, I'm happy to see you again. In today's video, I'm going to teach you Fetch-Decode-Execute Cycle. In the previous video, we talked about anatomy of a computer and I defined it as the study of components and the internal working of a computer. Throughout the video, we've seen the components of computer relatively in detail. And to get it well understood, in this video, we'll talk about the internal working of a computer system, which is basically the Fetch-Decode-Execute Cycle. If you haven't watched the previous video I'm longing for, I will highly recommend that you go watch it because it's like a prerequisite to this one. I'll put the link in the description below, so feel free to check it out. And without any further ado, let's get started. When we studied the CPU, we saw that it works incessantly insofar as the computer is on the go. That is, it reads data from the RAM, processes it, and then writes information back to the RAM continuously as long as the computer is on. This is simply the Fetch-Decode-Execute Cycle, also known as the execution cycle. In the previous lecture, we gained an understanding of what the RAM and the hard disks are, but we still don't know how they relate to each other. Perhaps we say the RAM is a fast memory that temporarily stores data, and we say the hard disk is a slow type of secondary memory that permanently holds the entire data and programs of the computer. In addition, we saw that the RAM isn't quarter as huge as the hard disk drive in capacity and size. So having known that the CPU is super fast, we can clearly understand that the hard disk can't operate in sync with the CPU. Meaning the hard disk is too slow to pass data to the CPU at the desired clock speed of the CPU. Now, to get around this problem, the RAM, which is relatively fast enough, is installed between the hard disk and the CPU, in the sense that it collects data that is more likely to be used by the CPU from the hard disk and passes it to the CPU. And when the CPU wants to store data, it passes it to the RAM, and then the RAM stores the data in the hard disk. So you can think of RAM like an interface or a gateway that sits between the hard disk and the CPU. It's time you know that the secondary memory doesn't really engage in this cycle. So for your information, the hard disk here is not part of that cycle. I just added it in the first place to get it known to you how it is related to the RAM. And now that we understood, it's better that I remove it. So let's get rid of the hard drive. We have to escape from this slideshow, and yeah, we delete it, and we delete this one too. Yeah, now it looks simpler and more understandable. To keep things simple, we purposely didn't add the registers. And with the aid of this simple and comprehensive diagram, and with my previous explanation, you might have understood why this cycle is called Fetch-Decode-Execute. If you haven't, it is simply because these are the three key things that happen in the cycle. You see the fetch, decode, and execute. 1, 2, and 3. Let's forget about this for the meantime. Now, looking closer at this diagram, we can see that the control unit fetches instruction from the RAM one at a time. It then decodes the instruction and pushes it to the CPU for execution. The ALU then executes the instruction and finally passes it to the RAM when needed. And at this point, RAM passes it to the imaginary hard disk drive. This process of fetch, decode, execute continues non-stop until the computer is put off. Now notice that this cycle is much more complicated than I explained when looked at in detail. But at this stage, we will simply digest it like this and we move. Okay, yes, I know exactly the question that is rattling in your head. And that is, if this cycle has the so-called much and complex stages, and the CPU does for one instruction at a time, like the trivial 1 + 1, how then are we able to get a quick and accurate response that 1 + 1 is 2? Well, the answer is that the CPU is insanely faster than you can ever imagine. Modern CPUs are capable of doing 5.20 GHz per second, which means 5.0 billion cycles per second. That number is astronomical, right? How cool is it to know that you too can check the speed of your processor? Well, let's give it a try. Let's first have this minimized. The first step is to click at this file icon in your taskbar and navigate to the sidebar and hover at this PC. So you right click and then you click on properties and boom, this is the speed of this system. It can do 2.30 gigahertz, which means it's capable of doing 2.3 billion cycles per second. I don't know how to check that in a Mac computer. Now that I shared mine with you, let me know the speed of your processor in the comments section. Now that we've got instruction cycle out of the way, let's take a deep breath and talk about family. Certainly not what you are thinking about. I mean, on this one, I'm going to give you a metaphor. In Nigeria, we have 3 major ethnic groups: Hausa, Yoruba, and Igbo Kwenu. Ye, Igbo Kwenu. Ye, Igbo Kwenu. Ye, Kwezwono. Ye. Yeah, I like that. But mind you, I recognize and admire other diverse ethnic groups, but for this example, with all due respect, I will go with the ones I mentioned. So for each of these ethnic groups, all the words in their language are practically formed by combining the alphabets of the English language we know right from our nursery classes. Though we might encounter words that mean the same thing across these languages, but mostly different words means different thing across these languages. For example, Uku means 3 in Hausa, 3 as in number 3. In Igbo, Uku means waste, as in waste product, while it might not even have a meaning in Yoruba. This same ideology is applied to processors, aka CPUs. They are of different families and different language, each one composed of 0 and 1s, that is the machine language. And similarly, different combination of zeros and ones have different meanings across different processor families. For example, 11110000 might mean delete in this processor family, and same 11110000 might mean save in that processor family, and might not even have a meaning in another processor family. Now, some of the very many processor families we have out there are Atom, Celeron, Core-i9, Itanium 2, Pentium, PowerPC, Spark, Xeon, x86, to list a few. That is all I have for you today. I hope you really enjoyed and understood it. Let me know your language in the comment section so I could respond with your native greeting. See you in the next video.